Hi students, in this video we are going to see about conditions of parallelism in model 1. Let us see. This parallelism is required in which of the areas where it is needed. What is the requirement of this parallelism means? First, it is required in the computation models of parallel computing and interprocessor communication in parallel architecture, and third one is integration of parallel systems into general environment. So these are the three main areas where this parallelism is highly required. What are those means? First one is computations models of parallel computing and interprocessor communication in parallel architectures, and third one is integration of parallel systems into general environment. Right. Then data and resource dependencies. When you go and see the parallelism, what are the conditions required for the parallelism means we need to learn about the data and resource dependency, and resource dependency. Likewise, these dependencies are divided into some forms. The main three forms are, first one is data dependency, and second one is control dependency, and third one is resource dependency. First, data dependency. What is meant by data dependence means data modified by one segment should not be modified by another parallel segment. So when you are going to execute in a parallelized environment, if the data modified by one segment, one piece of execution should not be modified in the another piece. Then control dependency. If the control flow of segments cannot be identified before runtime, then the data dependency between the segment is a variable. Then third one is resource dependency. Even if the several segments are dependent in other ways, they cannot be executed in a parallel. They are in sufficient processing resources. Say for example, functional unit. So likewise, we have the three different forms of dependencies. Let us see one by one in this video. Dependence graph. So first dependency is data dependency. How we can visualize this dependency means using one graph. It is a visualized representation of showing the dependency between data, control and resource. They are following some notations and symbols and representations to explain the different types of dependencies. So that is what the dependence graph is used to describe a relation between the statements, and the nodes corresponds to the program statements, and directed edges with different labels shows the ordered relation among the statements. Right? So this is the definition of dependence graph. In this video, we are going to see about the first dependence that is called as data dependence. Okay, data dependence 1. The first relation is flow dependence. So how it is denoted means this S1 dot S2. A statement S2 is flow dependent on statement S1 means if the execution path exists from S1 to S2, at least one output of 1 is used as a input to the S2. This is the, let us see, we'll see in the later with example how this data dependencies will be executed. Now we'll learn the definition of each dependence. This is called as flow dependence. Second dependence is anti-dependence denoted by S1 and S2. This statement S2 is independent on statement S1 if S2 follows S1 in program order, or if output of S2 overlaps the input of S1. What is the third dependence means? Output dependence denoted by this S1 arrow mark S2. The two statements are output depend if they produce the same output variable. That is called as output dependence. And the fourth one is IO dependence. Read and write are the IO statements. IO dependence occurs when same file is referenced by both IO statements. So I'll give you first we'll see the definition of each difference. We'll see one tutorial class with how this dependence graph will be written. Okay. The third data dependence is unknown dependence. So a subscript of a variable is itself subscripted. Subscript does not contain the loop indices. That means that subscript and all will not be known to everyone. That is what it is called as unknown dependence. This parallel execution of program segment which do not have total data dependence can produce a non-deterministic result. Okay, so this parallel execution of this program segments do not have a total dependence can produce non-deterministic. If the execution of this program which do not rely on the any data means that will can produce that non-deterministic results. So this is what about data dependence. I hope you understand. I will catch you in the next video with good live tutorial of how this data dependence graphs and everything and all will be generated, and will with one one solved problems and examples. Yes, thank you. I hope you understand. I will catch you in the next video about next topic. Thank you.